Good morning everyone. You might have noticed on the Ockbrook STEM Twitter account that I have posted this document, which is a series of Easter holiday physics activities for you to have a go at, and I've posted 3 activities per day. So if you look on the table, there were activities for Monday, 3 activities for Tuesday, Wednesday, Thursday, Friday, and so on. And I just wanted to run through what these 3 activities are. And the first one is read a story. So all of these links will take you to a physics related story, and the first one is a very sad story about the story of the radium girls, which year 9 physics students have studied this year whilst they've been studying radioactivity. The third challenge is called Lockdown Physics, and if you go onto Twitter and search for hashtag Lockdown Physics, it will take you to a practical challenge that you can do at home, and it will broaden your physics knowledge. And today's challenge is the day 6 challenge. That's not been posted yet, but it will be posted later in the day. And the third task is a Fermi question, and a Fermi question is one which has a seemingly impossible to calculate answer, but you have to use your skills of estimation to come up with an answer. And as you go up to high levels of study of physics, estimating becomes an important skill for you to develop. And I just want to run through the one I posted for yesterday, which is to estimate the number of hairs on the human head. So how are we going to estimate the number of hairs on a human head? Well, the first thing we're going to assume is that the head is shaped like a sphere, like this tennis ball. It's spherical in shape. Now I know in reality human heads aren't spherical in shape, but because this is an estimating calculation, we're going to start off with that point. And the next thing we're going to say is that only half of the human head is covered in hair. So the area of a sphere, the surface area of a sphere, is given by 4 pi r squared, and if only half of the human head is covered in hair, then the amount of area that's covered in hair is 2 pi r squared. And we're going to say that the approximate radius of the human head is 10 centimeters. So the amount of amount of area covered in hair is given by 2 pi r squared, which is 2 pi times 10 squared, which is 200 pi centimeters squared. And we're going to approximate that as being 600 centimeters squared. So we've now got an approximate value of the surface area of the human head covered in hair. Now if I'm going to approximate that 1 centimetre of, if I counted the number of hairs in 1 centimetre, I would find about 15 hairs. So if I just measured a length, counted the number of hairs, I would find 15 hairs. If I then drew a square 1 centimetre with dimension of 1 centimetre, the number of hairs I would find in that square would be 15 times 15, which is 225, and we're going to approximate that to 200. So in 1 centimetre squared I would find approximately 200 hairs. So if the surface area of the human head is 600, the number of hairs I would find on the human head are 600 times 200, and so you would get a final answer of 120,000 hairs. And if you look on Google, and I've looked on various number of sites, that they say that the number of hairs on the human head is about 100,000. So this estimation has come up quite close, and it's quite incredible really to think about the fact that there are approximately 100,000 hairs on your head. So I just thought I'd show you how I would go about a Fermi question, and Tuesdays is a little bit easier, where you have to estimate the number of times your heart beats in a lifetime. But do contact me via email, or do post to OpBrookeSTEM at Twitter if you have tackled any of the lockdown physics challenges, or if you want to show me the calculation, your estimations for those daily tasks.